Hi everyone. Today we're going to study sum and difference identities. Finding the exact value of the sine, cosine, or tangent of an angle is often easier if we can rewrite the given angle in terms of two angles that have known trigonometric values. We can use the special angles, which we can review in the unit circle as shown. We have this unit circle here. There are coordinates for each of the given angles. Note that the x-coordinate corresponds to the cosine theta, while the y-coordinate corresponds to sine theta. Let's go now to the sum and difference identities. Let's begin with the sine of alpha plus beta angles. This is equal to sine alpha times cosine beta plus cosine alpha times sine beta. The sine of the angles alpha minus beta is equal to sine alpha times cosine beta minus cosine alpha times sine beta. Please note some patterns here for the sum and difference of the sines. I will go now to the cosine. For the cosine of alpha plus beta, this is equal to cosine alpha times cosine beta minus sine alpha times sine beta. For the cosine of alpha minus beta equals cosine alpha times cosine beta plus sine alpha times sine beta. Please see also some similarities or patterns for the sum and difference of the cosine. I will go now to the tangent. For the tangent of the angles alpha plus beta equals tangent alpha plus tangent beta all over 1 minus tangent alpha times tangent beta. For the tangent of the angles alpha minus beta equals tangent alpha minus tangent beta all over 1 plus tangent alpha times tangent beta. See and observe the similarities of the sum and difference for the tangent of two angles. Let's see this example 1. Find the exact value of cosine 75 degrees. We're going to split this 75 degrees into 45 degrees plus 30 degrees. We're going to use 45 degrees and 30 degrees for the cosine because these are special angles with respect to cosine. So we say that cosine 75 degrees, our problem here, equals the cosine of the angles 45 degrees plus 30 degrees. Let's begin by writing the formula. The formula is here now, and substitute the given angles. The alpha corresponds to the 45 degrees and the beta is the 30 degrees. So we write the cosine of 45 degrees plus 30 degrees equals cosine 45 degrees times cosine 30 degrees minus sine 45 degrees times sine 30 degrees. From the unit circle, we will get the corresponding values for the cosine 45, cosine 30, sine 45, and sine 30 degrees. So we have now square root of 2 over 2 for cosine 45 degrees. square root of 3 over 2, that is cosine 30 degrees, minus square root of 2 over 2 for the sine 45 degrees, times 1/2, and this is sine 30 degrees. Simplifying now, we have square root of 6 over 4 minus square root of 2 over 4. We have a common denominator here, so we'll put this together. So we have square root of 6 minus square root of 2 all over 4. This is the final answer. Example 2. Use the sum and difference identities to evaluate sine 15 degrees. Let's note that sine 15 degrees we can write as sine of 45 degrees minus 30 degrees. So we write the formula for the sine alpha minus beta. Substituting the corresponding values, we have sine 45 degrees minus 30 degrees equals sine 45 degrees times cosine 30 degrees minus cosine 45 degrees times sine 30 degrees. Here are the values of the special angles that we need. Substituting the values now, we have square root of 2 over 2 for the sine 45 degrees, square root of 3 over 2, that is the cosine 30 degrees, minus square root of 2 over 2 for cosine 45 degrees, times 1/2, that is the sine 30 degrees. Simplifying our values here, we have square root of 6 minus square root of 2 all over 4. This is the final answer. Example 3. Find the exact value of tangent 15 degrees. In this case, we're going to write tangent 15 degrees equals tangent of 60 degrees minus 45 degrees. Our formula for the tangent alpha minus beta is here. Substituting the corresponding angles, we have now the tangent of 60 degrees minus 45 degrees equals tangent 60 degrees minus tangent 45 degrees all over 1 plus tangent 60 degrees times tangent 45 degrees. Our values for the tangent 60 degrees and tangent 45 degrees are here. We can get these values from our unit circle a while ago, considering that the tangent A is equal to sine A over cosine A. Now, let's do the substitution. We have square root of 3, that is tangent 60 degrees, and this one is the value of tangent 45 degrees, all over the constant 1 plus square root of 3 times 1. Simplifying this, we have now the square root of 3 minus 1. In our denominator, we simply put the square root of 3 first, followed by plus 1. This is now the final answer. Example 4. Using the formula, find the exact value of cosine of the quantity 5 pi over 4 minus pi over 6. This is our formula for the cosine of two angles, that is alpha minus beta. We write the cosine of the difference of two angles here. The first angle is the alpha minus the second angle is the beta. Using this pattern, we can rewrite this problem into like this. Cosine of 5 pi over 4 times cosine of pi over 6 plus the sine of 5 pi over 4 times the sine of pi over 6. Let us find the values of the cosine and sine of the angles respectively. We can show our circular chart here. Then let us locate the two angles, the 5 pi over 4 and the pi over 6, and it is here. Let us now get the values for the cosine and sine of the angles. We know that for the cosine, this is the x-coordinate of the angle. So the cosine 5 pi over 4 is negative square root of 2 over 2 times the cosine of pi over 6, the value is the square root of 3 over 2 plus the sine of 5 pi over 4. This is the y-coordinate of the angle. So we write here negative square root of 2 over 2 times the sine of pi over 6. Also, we get the y-coordinate. So we write here 1/2. Let us evaluate the products respectively. For the first group, negative square root of 2 over 2 times square root of 3 over 2. That is negative square root of 6 over 4 plus we multiply negative square root of 2 over 2 by 1/2, and the product is negative square root of 2 over 4. Let us now combine the two fractions. We can see that we have same denominator, so the final answer is negative square root of 6 minus square root of 2 all over 4. This is the final answer. Today we're going to study sum and difference formulas for cofunctions. After studying the sine, cosine, and tangent functions for the sums and differences of angles, we can use them to do the same for their cofunctions. You may recall from right triangle trigonometry that if the sum of two positive angles is pi over 2 or 90 degrees, those two angles are complements. And the sum of the two acute angles in a right triangle is pi over 2, so they are also complements. In figure, notice that if one of the acute angles is labeled as theta, then the other acute angle must be labeled pi over 2 minus theta. Notice also that sine theta equals cosine of the angle pi over 2 minus theta. Sine theta here is the opposite over hypotenuse. Thus, when two angles are complementary, we can say that the sine of theta equals the cofunction of the complement of theta. In this case, that is cosine. Similarly, tangent and cotangent are cofunctions, and secant and cosecant are also cofunctions. From these relationships, the cofunction identities are formed. Let's go now to cofunction identities. A while ago, we said that sine and cosine are cofunctions. So we write here sine theta equals cosine of the angle pi over 2 minus theta. Also, cosine theta equals sine of the angle pi over 2 minus theta. Also, secant and cosecant are cofunctions. So we have here secant theta equals cosecant of the angle pi over 2 minus theta. Also, cosecant theta equals secant of the angle pi over 2 minus theta. The tangent and cotangent are cofunctions. So we write tangent theta equals cotangent of the angle pi over 2 minus theta. This cotangent theta equals tangent of the angle pi over 2 minus theta. Let us see this example. Write tangent pi over 9 in terms of its cofunction. The cofunction of tangent theta equals cotangent of the angle pi over 2 minus theta. In our example here, theta is this pi over 9. Substituting this, we have now tangent pi over 9 equals cotangent pi over 2 minus pi over 9. Let us now simplify this pi over 2 minus pi over 9. We have here fractions with different denominators. Let us first find the LCD and consider equivalent fractions. We have now this 9 pi over 18 that is equivalent to pi over 2 minus 2 pi over 18. This is equivalent to this pi over 9. Let us subtract this 9 pi minus 2 pi. So we have 7 pi over 18. Therefore, tangent pi over 9 equals cotangent 7 pi over 18. This is the final answer. Problem 1. Simplify the expression. Let's have letter A. Cosine of the two angles pi over 2 minus x. Our formula for the cosine of difference of two angles equals cosine alpha, this is the first angle, times cosine beta, plus the sine alpha times sine beta. The given problem we write here, then we apply our formula. So we get cosine of pi over 2 times cosine of x plus sine of pi over 2 times the sine of x. With our unit circle here, let us get the values respectively. For the cosine pi over 2, that will be 0 times the cosine x plus the sine pi over 2 is equal to 1 times sine x. This 0 times cosine x becomes 0. Then 1 times sine x is simply sine x. Letter B. The sine of the sum pi over 3 plus x. This is our formula. Let us now substitute the values. So we have this sine pi over 3 plus x equals sine of pi over 3 times cosine x plus cosine of pi over 3 times sine x. With our unit circle here, let us write the values. For the pi over 3, that is sine, that will be square root of 3 over 2 times the cosine x plus the value of cosine pi over 3, that will be 1/2 times sine x. Then we simplify each group. Cosine x multiplied to the square root of 3 all over 2 plus the other group becomes sine x over 2. Then we can combine these two fractions with same denominator. So we have square root of 3 cosine x plus sine x all over 2. Problem 2. Simplify the expression. Let's have letter A. Cosine of 5 pi over 4 plus x. We have sum of cosine. The formula is here. Then we substitute the values. We copy the problem. Then this is equal to the cosine of 5 pi over 4 times cosine of x minus the sine of 5 pi over 4 times sine x. With our unit circle, let us get the value of cosine 5 pi over 4. That will be negative square root of 2 over 2 times cosine x, then minus this sine 5 pi over 4, that is equal to negative square root of 2 over 2. Then we simplify further. For the first group, we have negative of square root of 2 times cosine x all over 2. Then negative by negative becomes positive. Then we write square root of 2 times sine x all over 2. We can simplify this expression. We can factor out the square root of 2 over 2. Then we write sine x first minus the cosine x. Letter B. The tangent of the angles pi over 4 minus x. With the difference of the tangent, this is our formula. And this expression becomes tangent of pi over 4 minus tangent x all over 1 plus tangent of pi over 4 times tangent x. We need the tangent pi over 4. Note that we can write this as sine of pi over 4 all over cosine of pi over 4. We can get the values from the unit circle. So that is square root of 2 over 2 for this sine pi over 4. For the cosine pi over 4, it is also same value, the square root of 2 over 2. That means numerator divided by itself is equal to 1. So we use this value in here. So this tangent pi over 4 is now 1 minus tangent x all over 1 plus the tangent pi over 4 is now replaced by 1 times tangent x. Multiplying 1 by tangent x is simply tangent x. So finally we have 1 minus tangent x all over 1 plus tangent x. Problem 3. Find the exact value algebraically, and then confirm the answer with a calculator to the 4th decimal point. We have here 4 expressions. Let's begin with expression A, sine 75 degrees. This 75 degrees we can rewrite as 45 degrees plus 30 degrees. Then with our formula, sine of alpha plus beta equals this expression. That means this sine of 45 degrees plus 30 degrees equals sine 45 degrees times cosine 30 degrees plus cosine 45 degrees times sine 30 degrees. With the unit circle, let us get the values and substitute here. Sine 45 becomes square root of 2 over 2. Cosine 30 degrees is square root of 3 over 2 plus cosine 45 degrees is square root of 2 over 2 times sine 30 degrees, that is 1/2. Let us now simplify the products respectively. For the first group, we have square root of 6 over 4 plus the second group is square root of 2 over 4. Then we can combine the fractions having same denominators. So we have square root of 6 plus square root of 2 all over 4. Using the calculator, the value is 0.9659. Note that Using your calculator, when you get sine 75 degrees, you will get same value. Letter B expression, sine of negative 15 degrees. We can rewrite this as sine of 30 degrees minus 45 degrees. Then with our formula, the sine of the difference, that is equal to sine alpha cosine beta minus cosine alpha sine beta. That means this expression is now equal to sine 30 degrees cosine 45 degrees minus cosine 30 degrees sine 45 degrees. With our unit circle, let us collect the values and substitute here. The sine 30 degrees is 1/2. The cosine 45 degrees is square root of 2 over 2. Then minus cosine 30 degrees is square root of 3 over 2. Then sine 45 degrees is square root of 2 over 2. Let us now simplify. In the first product, we have square root of 2 over 4 minus second product square root of 6 over 4. We can combine the two fractions having same denominators. So we have square root of 2 minus square root of 6 all over 4. Using calculator, the value is negative 0.2588. Note that when you get the value of sine negative 15 degrees in your calculator, you will get same value. Expression C, the cosine of 165 degrees. We can write this as cosine of 120 degrees plus 45 degrees. Our formula for the cosine of sum, we have cosine alpha, cosine beta, minus sine alpha, sine beta. That means this cosine 120 degrees plus 45 degrees is equal to cosine of 120 degrees cosine 45 degrees minus sine 120 degrees sine 45 degrees. With a unit circle, we will get the values. So cosine 120 degrees is negative 1/2. Cosine 45 degrees is square root of 2 over 2 minus sine 120 degrees is square root of 3 over 2 times sine 45 degrees is square root of 2 over 2. Let us now simplify the products respectively. For the first group, we have negative square root of 2 over 4 minus the second group is square root of 6 over 4. Having same denominators, we can simplify this as negative square root of 2 minus square root of 6 all over 4. When we simplify this using calculator, the value is negative 0.9659. Note that when you use calculator to get cosine of 165 degrees, you will get same value. Expression D, tangent 75 degrees. We can write this as tangent of 45 degrees plus 30 degrees. With the sum of the tangent, this is our formula. Tan of alpha plus beta equals tangent of alpha plus tangent of beta all over 1 minus tangent alpha tangent beta. Therefore, the expression tangent 45 degrees plus 30 degrees is now equal to tangent 45 degrees plus tangent 30 degrees all over 1 minus tangent 45 degrees times tangent 30 degrees. Here is the unit circle, but take note, for the tangent 45, this is equal to sine 45 degrees over cosine 45 degrees. Then we get the values of sine and cosine of 45 degrees respectively. In the numerator, that will be square root of 2 over 2 all over the denominator is square root of 2 over 2. That means the numerator is divided by itself. The answer is 1. What about tangent 30 degrees? This is equal to sine 30 degrees over cosine 30 degrees. In our unit circle, the sine 30 is 1/2 all over. The cosine 30 is square root of 3 over 2. From here, we can cancel the 2 and the 2. That means this is equal to 1 over square root of 3. We're going to use these two values in our fraction. Substituting now the values, we have 1 plus 1 over square root of 3 all over 1 minus 1 times 1 over square root of 3. In the denominator, we can simplify this portion like 1 over square root of 3. For this numerator, we can rewrite this as square root of 3 plus 1 all over square root of 3 all over. In the denominator, we can rewrite this as square root of 3 minus 1 all over square root of 3. From here, we can see that the square root of 3 as denominators are equal, so we can cancel from here. Then we rewrite the square root of 3 plus 1 all over square root of 3 minus 1. We can use the calculator to simplify this fraction, so we get the value 3.7320. Note that using your calculator to get the tangent of 75 degrees, you will get same answer.